By now you've worked through Python from control flow all the way up to decorators, async, and production APIs. This capstone pulls every one of those skills into a single real project, a habit tracker API with token-based auth, a proper relational database, full test coverage, a Dockerfile, and a CI pipeline. Let's build it, piece by piece. This is a FastAPI app backed by SQLAlchemy, with a user-to-habit to check-in relationship. It ships JWT-based register and login, full CRUD for habits scoped to whoever's logged in, custom exception classes that map cleanly to HTTP error responses, a pytest suite covering auth and access control edge cases, and a Dockerfile plus a GitHub Actions workflow to ship it. Before writing any logic, look at the shape of the project. Everything lives under one habit_tracker folder, split into an app package, a tests package, and the packaging and deployment files sitting right alongside them. Database.py owns the engine and the session, models.py defines the tables, schemas.py defines what goes in and out of the API, security.py handles hashing and tokens, CRUD.py holds the actual database operations, errors.py defines the custom exceptions, and main.py wires all of it into FastAPI routes. The production dependencies are deliberately small. FastAPI and Unicorn to serve it, SQLAlchemy for the database, Python Jose for JWT tokens, passlib with bcrypt for password hashing, and pydantic settings for configuration. On top of that, the dev requirements add pytest for the test runner, HTTPX so FastAPI's test client can make requests, and pytest COV to measure how much of the app the tests actually exercise. Now let's build the foundation, the database connection, the tables themselves, and the errors the app can raise. Database.py sets up a SQLAlchemy engine pointed at SQLite by default, though it reads database_URL from the environment so you can swap in Postgres later. Get_DB is the classic FastAPI pattern, a generator that yields one session per request and always closes it in a finally block. 3 tables, user, habit, and check-in, wired together with SQLAlchemy relationships and cascading deletes. Notice the unique constraint on habit_ID and day on the check-in table that pushes the no duplicate check-ins rule down into the database itself, instead of trusting application code to always remember to check. Every domain-specific failure gets its own exception class, username already taken, invalid credentials, habit not found, already checked in today. They all inherit from one habit tracker error base, which is what lets main.py catch all of them in a single place. With the data layer in place, next comes the 2 files that decide what's allowed in and who's allowed to do it. Security.py has 3 jobs: hash and verify passwords with bcrypt through passlib, mint a JWT access token that expires in 60 minutes, and decode incoming tokens and get_current_user a FastAPI dependency that every protected route relies on, raising a 401 the moment the token is missing, invalid, or expired. The pydantic schemas do double duty as validation and documentation. User create enforces a minimum password length and a username pattern before anything touches the database. Habit with check-ins extends habit out to nest a habits check-ins in the response, and config_dict from _attributes lets these models read straight off the SQLAlchemy objects. Now the part that actually does the work, the database operations, and the FastAPI routes that call them. Look closely at every habit-scoped query in here. They all filter by owner_ID equal to the current user's ID. That's the real access control core of this app. A user can never read or modify someone else's habits, because the database query itself won't return them. And when a duplicate check-in hits that unique constraint, the integrity error gets caught and turned into a clean already checked-in error instead of a raw 500. Main.py registers one exception handler that maps every custom error to the right status code in a single dictionary. Username taken becomes 409, bad credentials become 401, habit not found becomes 404. Register and login are the only 2 open routes, login exchanges a username and password for a JWT. Every habit route after that depends on get_current_user, so there's no way to hit them without a valid token. Create, list, get with its nested check-ins, delete, and the check-in endpoint itself all just delegate straight to CRUD.py, keeping the routes thin and the actual logic in one testable place. Code you can't verify isn't finished. Here's the pytest suite that proves auth, CRUD, and access control all actually behave the way they're supposed to. FastAPI spins up a fresh in-memory SQLite database for every test and overrides get_db so the app uses it instead of the real one. The auth_headers fixture goes one step further. It registers and logs in a real user, then hands back ready-to-use authorization headers for any test that needs one. Test_auth.py walks through the happy path and the failure paths. Registering succeeds, a duplicate username gets rejected with 409, a correct login returns a token, a wrong password returns 401, and hitting a protected route with no token at all returns 401 before any business logic even runs. This test creates a habit, checks in once successfully, then tries to check in again for the exact same day. That second call should fail with a 409, which confirms the unique constraint down in models.py and the integrity error handling in CRUD.py are actually connected end-to-end, not just written and hoped for. This last test is the whole point of the access control model. Two separate users, Ada and Grace, each register and log in. Ada creates a habit, and when Grace tries to fetch it with her own valid token, she gets a 404 not a 403 because the API refuses to even confirm that habit exists for anyone but its owner. A project isn't done until it can run somewhere other than your laptop and prove itself automatically on every push. That's what the last two files are for. The Dockerfile is deliberately minimal, start from Python 3.12 Slim, install just the production requirements, copy in the app folder, expose port 8000, and run Unicorn as the container's entry point. No dead dependencies, no test files, just what the running service actually needs. The CI workflow has two jobs. The test job installs the dev requirements and runs pytest with coverage on every push and pull request. The build job only runs on the main branch, after tests pass, and builds the Docker image tagged with the commit SHA so nothing broken ever gets built, let alone shipped. To run it yourself, install the dev requirements, run pytest with coverage to see it all pass, then start the server with Unicorn reload. From there you register a user, log in to get a token, create a habit with that token, and post a check-in against it. The exact same flow the tests already proved works. Step back and this project is really a map of the whole path. Level 1's functions, control flow, and data structures run through every file. Level 2 shows up as the OOP in models.py, the custom exceptions, and the whole idea of testing. Level 3 is the SQLAlchemy layer and the FastAPI routes themselves. And Level 4 is everything that makes this production-shaped, real auth, structured error handling, testing at scale, and shipping it with Docker and CI. If you want to push further, add a streak endpoint that computes someone's current consecutive check-in run, add rate limiting on login to slow down credential stuffing attempts, or swap SQLite for Postgres with Docker Compose. And if you built this whole project, you've genuinely completed Python mastery path, from entry level all the way to master, with real working code at every single step. That's the full Habit Tracker API, start to finish. Every file, every test, and the whole CI pipeline are pulled straight from this one Capstone lesson. Links below if you want to clone it and run it yourself.